Have you ever looked up at the sun and noticed its bright yellow hue? It's a sight that has fascinated humans for millennia. It's a familiar sight, leading many to believe that our star is, in fact, yellow. This belief is so strong that it has influenced countless works of art and literature. But what if I told you that the sun isn't yellow at all? This revelation might challenge everything you thought you knew about our closest star. This might come as a surprise, but the sun, the star that graces our sky, is not the color we often perceive it to be. In reality, the sun emits light that is essentially white. From our vantage point on Earth, the sun often appears as a vibrant yellow orb, especially during sunrise and sunset. This is due to the scattering of shorter wavelengths of light by the Earth's atmosphere. This perception is so ingrained that it permeates our culture, from children's drawings to artistic representations. We grow up associating the sun with the color yellow. The color yellow becomes synonymous with the sun, solidifying its image as a golden celestial body. This cultural association is powerful and enduring. However, this familiar yellow hue is actually a result of the way our atmosphere interacts with sunlight. The scattering of light causes the shorter blue wavelengths to scatter out, leaving the longer yellow and red wavelengths to dominate our view. So the next time you look up at the sun, remember that its true color is a brilliant white, and what we see is a beautiful illusion created by our planet's unique atmosphere. Earth's atmosphere plays a crucial role in how we perceive the sun's color. As sunlight passes through this gaseous envelope surrounding our planet, it undergoes a phenomenon known as scattering. This scattering effect is more pronounced for shorter wavelengths of light, particularly blue and violet. Imagine the atmosphere as a giant filter that preferentially removes some colors from sunlight before it reaches our eyes. During the day, when the sun is high in the sky, shorter wavelengths of light are scattered away, leaving the longer wavelengths like yellow and orange to dominate our perception. This is why the sun appears yellow, even though it's not its true color. If you were to venture beyond Earth's atmosphere, into the vacuum of space, you would witness a very different sun. Without the atmospheric filter to alter its appearance, the sun shines with a brilliant white light. This is because sunlight is composed of all the colors of the rainbow, a fact easily demonstrated by passing sunlight through a prism. The prism separates the different wavelengths of light, revealing the full spectrum of colors present. In space, where there is no atmosphere to scatter specific wavelengths, all these colors combine to create the sun's true color white. Astronauts who have had the privilege of observing the sun from space can attest to its dazzling white brilliance. Section 4. Scattering sunlight, the science of color. To understand why the sun appears yellow from Earth, we need to delve a bit deeper into the science of light scattering. Light from the sun, which we perceive as white, is actually composed of a spectrum of colors, each with different wavelengths. When sunlight enters our atmosphere, it collides with air molecules, water vapor, and dust particles. These particles are much smaller than the wavelength of visible light, causing the light to scatter in various directions. These collisions cause the light to scatter in different directions. This phenomenon is known as Rayleigh scattering, named after the British scientist Lord Rayleigh who first described it. Shorter wavelengths of light, such as blue and violet, are scattered more effectively than longer wavelengths, such as red and orange. However, our eyes are more sensitive to blue light, which is why we predominantly see a blue sky. This is why the sky appears blue during the day. The scattered blue light reaches our eyes from all directions. The blue light is scattered in all directions by the tiny molecules of air in Earth's atmosphere. However, the sun itself appears yellow because the scattered blue light has been removed, leaving the longer wavelengths to dominate our perception. During sunrise and sunset, the sun's light has to pass through more of the Earth's atmosphere, scattering even more blue light and allowing the reds and oranges to become more prominent. Section 5. Beyond yellow, the sun's true spectrum. While we perceive the sun as yellow from Earth, its true color, white, is a testament to the full spectrum of light it emits. This light, ranging from infrared to ultraviolet, carries energy that sustains life on our planet and influences various atmospheric phenomena. The sun's spectrum is not perfectly uniform. It peaks in the green part of the spectrum. However, our eyes do not perceive this peak as green because all the colors blend together to create the perception of white light. Understanding the sun's true spectrum is essential for various scientific fields, including astrophysics, climate science, and solar energy research. Section 6. Stellar evolution, a colorful life cycle. The color of a star, including our sun, is not static. It changes over billions of years as the star evolves. This transformation is a fascinating journey through time and space, revealing the dynamic nature of the universe. Stars begin their lives as massive clouds of gas and dust, which eventually collapse under their own gravity. These clouds, known as nebulae, are the stellar nurseries where new stars are born. As the core of this collapsing cloud heats up, nuclear fusion begins, igniting the star and giving it its characteristic color. This process marks the birth of a new star, a beacon of light in the vast darkness of space. The color of a star is determined by its surface temperature, which in turn is related to its mass and age. Younger, more massive stars burn hotter and appear blue or white, while older, less massive stars are cooler and appear red or orange. Hotter stars appear blue or white, while cooler stars appear red or orange. This color spectrum is a visual representation of the star's life cycle and its ongoing changes. Our sun, currently classified as a yellow dwarf star, will eventually exhaust its nuclear fuel and expand into a red giant, engulfing the inner planets, including Earth. This dramatic transformation will mark the end of its life as a main sequence star and the beginning of its final stages. Section 7. White-hot truth, dispelling the myth. So, the next time you gaze upon the sun, remember that its yellow hue is an illusion created by our atmosphere. In the vast expanse of space, our star shines with a brilliant white light, a testament to the full spectrum of colors it emits. The sun's true color, white, is a reminder of its immense power and the fascinating interplay of light and matter. By understanding the science behind this celestial phenomenon, we gain a deeper appreciation for the wonders of our universe and the precious star that graces our sky.